Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. How you guys and girls doing? Oh my god, I hope you learned something from the last video. Basically, what we did was we sent a lot of data to our graphics card and we got a little triangle on screen. Now this video, we're going to change it up a little bit. I'm going to show you how to actually use the index array for good. Now in this case, it didn't do any good. We just had 3 vertices and we had 3 indices, alright? But I want to show you the reason that they're good. Now in order to get a triangle on screen, you need 3 vertices. You can't just use one more and expect it to pop out. You need to make 3 vertices in the order that we specified. That was the front face, which was counterclockwise. So you want to make 1 vertex on top, left, bottom, right, and they connect like that in the graphics card. It does that for you in the triangle or primitive assembly stage, which is kind of complicated. I don't know a lot about that, but anyway, so in order to get a square, you can't just put 4 vertices. You need 6. All right, you need duplicates of these. Now I want to show you why we'll need that. So we'll just duplicate this triangle right now. Boom. Put another little comma right there. All right, just like that. This will automatically change for us. Then this triangle, this one, this is the top vertex, and we want to change it. We want to make the top vertex point, not look like a nice triangle. It should look like a kind of weird triangle like this. So we want to shove that point to the left. To do that, we need to do minus 0.5 because it goes from -1 here to 1 here. 0 is in the center and stuff like that, and the bottom would be -1 in y, and the top is 1 in y. So that's how we have it here. Now this point is to the left. So if I just show you this, actually without this just yet, I'm going to show you how that works. It looks like this. Now we want a triangle that looks like this to make a square. Boom, boom, boom. Alright, so we're going to start off by this point. Or we can start with this point. Bottom and top. So this point we're going to keep. The blue one we're going to keep. So the red one, let's just copy these again. Alright, this is triangle 2. This is triangle 1. So the red one we're going to keep. It's going to go to the blue one, which is RGB. This is the blue one. The other one is going to be here. RG. We'll just copy this blue one here. Remember, clockwise order. And the green one has to be on the top right. So it should be 0.5. Green was at the bottom, so it has to be top 0.5 like that, and to the right 0.5. So let me just see if that works. I'm pretty sure that should work. If I just comment this out, that should be a, if it doesn't show, so yeah, that's what I want. So let's just do this, and let's use the old one, the one that doesn't use our indices because we haven't changed them yet. It's gonna draw all our triangles that we have, all our points that we have, and it gives us a square. All right, just like that. Now I want to change that green vertex to look a little different. The green one, RGB, no wait, RGB, so this is the green one. I don't know, I'll just put a 1 there, and this should make it look a little different. So now it's yellow. See, that point is different from this one. That's blue, that's red, and it interpolates everything in the object. Remember, I said the primitive will be completed after the vertex shader sometime, and then we'll get each pixel within that primitive, and it will kind of mix and match everything as we go. Any other things you send in will be interpolated as well. There are options to make sure that it does not interpolate. Then you'll have some weird squares and shit. And that's pretty cool too. We'll go through that a little later. I think, let me just try that out actually. Let me just see out. Let me see if you can do it. Clamp, no, strict, I think. I don't know, it's just gonna crash. All right, it wasn't strict. I'll check out that keyword later because I don't remember it. You probably, if you know, just go ahead and play with that. If you don't, we'll talk about that later. But anyway, we have our square. Now see, there's 6 vertices here, 2 triangles making up a square. We don't need that when we have an index array. So we're gonna do this. Let's go back to using our indices that we have stored in our VAO that is bound. Instead of just the vertex array, which we have the vertices, the 6 vertices, we're going to use our indices. Now, how can we order these in order to get a square out of 4 of these? All right, what we could do now is just say that is one triangle. This is triangle 1, and the second triangle is going to be 0, 1, 2, 3, 4, 5. 3, 4, 5. Triangle 2. So this is a way that we can do. Then we're gonna get the same effect, hopefully. Yeah, we got the same effect. Now if I remove the triangle, it won't print that one triangle out, I think. Yeah, I just printed that one out. Alright, so see, here we go. But if, like some of you might have noticed, we have duplicates. Remember, the red and the blue one are exact duplicates. We don't need these two or one of these sets. So I'm just gonna remove these 2 duplicates that we have. Boom, they're gone. Now you're like, what? Now we can't create triangles, but that's just what I said. We can reuse these now. So which ones were the duplicates? Well, how did we go? We went from red and we took the blue one. So it's 0, 2, 0, 2, 3. 0, 2, 3. So we're using one triangle is created by using 1, 2, 3, and the other one is using 0, 2, 3. 0, 1, 2, 0, 2, 3. And this should give us the same, hopefully give us a square with 2 triangles. Boom, boom. Now I can show you that they're triangles by just ignoring the first one, and we'll get a nice little triangle on top. That's a triangle. And I can show you that the other one, the first one, is a triangle by doing this. Boom. All right. But if I just did this, we'd get an error. I'm pretty sure, because it expects an even number. This is just going to show us the first one again until we give it enough vertices to, whoops, there we go, in order to create a triangle. And that's about it for this video, I guess, but I just want to show you something cool that you can play around with. If you remember the OpenGL option we had, GL fill, if you just do GL triangle or GL line here, whoops, GL line, you should see everything in lines. Yep, you can see the outline of everything. All right, and that's, yeah, that's pretty fun to play around with. And then you have GL fill, which just fills everything for us. So that's it, guys and girls. That's just a little short intermediary video and explaining how all of that works. Keep learning about shaders. They're really important. Why the shaders work as they do, why we have them, and how we can play around with stuff. Now we could move. I could show you that as well because we have time. I could just move this vertex position plus 0.2.0.2f. I wonder what happens if you just do this. Yeah, we moved every vertex to the top because it runs once per vertex. It'll run for this vertex first. Okay, we'll move it. Run for the next one, we'll move it. Run to the next one, we'll move it. And there are actually 6 vertices it runs for. We can't, because they're duplicates, right? Twice for this one, twice for this one, and all that stuff. So it'll run and move everything to the top. You don't usually want if statements in these, you know, these beautiful lines, but I think you can if vertex position dot x is greater than 0.0 f, then I think if this doesn't work, you know, try to play around with something similar. plus equals 0.2f. This might not work because this is probably not how you options for link. Oh, okay. Probably something you can do here, something with varying or something. Varying, maybe. No, that didn't work. Okay, you know what? Never mind that. That was just a dumb thing to do. Try to figure that out. I'll try to figure it out as well, just to play around with it. And yeah, it should be fine. There we go. Yes, so go ahead, learn OpenGL.com. Check that out. Check out why that didn't work. Probably a good challenge for you. And I'll see you guys in the next video. We'll probably talk about some more interesting stuff like rotating and all that stuff. I'll think about it. I'll see what the next video will be about. But something fun nevertheless. Take care. Keep learning. I wish you all the best. And I'll see you in the next video, alright? Bye-bye.